linked representation requires the data requires the memory area, not necessarily consecutive. So it does not require consecutive memory area. If it is available, okay. It is not available, wherever it is free, it can make use of it. And one more point which I forget to give in comparison with linear representation is, in linked representation, the items can grow or shrink dynamically. That is one major advantage. In linear representation, once you fix, of course you can allot memory area dynamically, as I told you, even in linear representation. But once you allot the memory area, it cannot grow or shrink. But in linked representation, it can grow or shrink dynamically. This is one more advantage which you should note, which I did not give in the last class. So linked representation can grow or shrink dynamically. During execution, it can grow or shrink dynamically. That means, suppose initially there may be 10 elements, later there may be 100 elements, later it may be 50 elements. So the entire data structure, can grow or shrink dynamically in linked representation. But in linear representation, whatever you fix, suppose if you allot memory area, of course dynamically for 50 element, it remains 50 element. Later you cannot change. If you want to do it, you have to do a lot of activity to allot one more area, copy the data. So it will be a lengthy process. But normally, generally, when you take linear representation, once we fix the size remains same. It will not grow or shrink. But in case of linked representation, it can grow or shrink dynamically. Now, one more point to note in linked representation is it is always required to have dynamic memory allocation. Of course, as I told you, even in linear representation, you can go for dynamic memory allocation. But without dynamic memory allocation, also you can have a linear representation directly array. You can go for array and have a static memory allocation, and you can use the array as linear representation. But in linked representation, you must go for dynamic memory allocation. That is one point to note. So in linked representation, dynamic memory allocation is compulsory. And when you take the dynamic memory allocation, so before we start the linked representation, the important point to note is dynamic memory allocation. No, this is one important thing in C, dynamic memory allocation. So we'll see what is dynamic memory allocation. And before we see what is dynamic memory allocation, just first we should know what is dynamic. Generally in programming, there are two things. One is static, another is dynamic. Anything that happens before execution, means during compile time, load time, or link time, whatever it is, before execution, it is static. Anything that happens during execution is dynamic. Anything that happens during execution is dynamic. Anything that happens during, before execution is static. So there is, when you take dynamic memory allocation and static memory allocation, there is dynamic linking, static linking. Linking is related with functions or methods. Memory allocation is related with allotting memory area to data items. So if memory is allotted before execution, it is static. The thing with when it is static, the problem is whatever you allot, that is remains same. It cannot be changed. In case of dynamic memory allocation, because the allotment happens during execution, so whatever required during runtime as per the requirements of the user, you can exactly allot. In case of static memory allocation, we are deciding the memory requirement before the execution begins. But only when the execution begins, sometimes we may know the exact requirements of the user. So in static memory allocations, what happens is, suppose if I go for an array, if I go for an array, suppose AR of 100, so I'm giving provision to store 100 numbers. This will be done before execution. And later during execution, suppose if the user is using 10 numbers, 90 number space is wasted. But during execution, if the user wants 110 numbers, then it is not possible. So in starting memory allocation, because the decision is made before execution, and the exact requirement is known only during execution, so there is either of memory wastage of memory is possible in starting memory allocation, and or there is insufficient memory. So one of these things may happen. So if you are going for bigger memory, it is wastage, and if you are going for smaller memory, user wants later more, then there will be insufficient memory. But in case of dynamic memory allocation, as per the user requirements, we can allot. So there is no wastage and no insufficient memory. So the memory allocation is given during execution, and in case of static memory allocation, the memory allocation is done before execution. Now, one more thing here is normally if you take the C language, the memory given to the program will be divided into several parts. So this is also you should know for dynamic memory allocation. So the memory, whatever given to the program, is divided into several parts. So several first part is the text, which is nothing but the program. Second part is data, which is nothing but static and global data. Then there is stock, which grows strings dynamically. There is heap. So this is the memory allocation to the program. So here, when you take text is nothing but the code what you have written. Data is nothing but the static and global variables. This consists of static and global variables. Static and global variables. So whether the static variable is local or global, it will get the data area, and this is divided into two. One is initialized data area, another one is uninitialized data area. So the static variables, which are static and global variables, which are uninitialized, are kept on one place, and in bulk they are initialized to 0. That is the reason why they are separated. So at a time they are initialized to 0. It is easy to fill the huge memory area with zeros rather than taking one item at a time and filling it with 0, assigning it with 0. So that is the reason why static and global variables which are not initialized are separated, and they are initialized at a time. Stock holds different data items. Mainly it holds local automatic variables. Even it holds the parameters, it holds the return addresses. So based on the function calling, stock grows and shrinks dynamically. Heap is the dynamic memory area. So when you take the memory, different variables gets its space from different places. So if it is constants, it is part of text. If it is static and global variables, it will get space here. If it is automatic variables, it will get space here. And heap is the area which can be used as dynamic memory allocation. Only one very important point to note here is only pointers get space from heap. Only pointers get space from heap. That means dynamic memory allocation means it is only for pointers. Even though the local the stock is a dynamic memory area which grows or shrinks, but it is automatic. So the stock is also dynamic memory area. If you take data area, which is fixed, text area, which is fixed, but stock and heap, they grow and shrink dynamically. But stock grows and shrinks automatically based on the calling of the function, and heap is the area which is for pointers, and it grows or shrinks based on the programmer, based on programmer's request. it will grow or shrink. It will grow or shrink. So this is one important point to note in dynamic memory allocation. So dynamic memory allocation, one point to note is it is only with pointers. Dynamic memory allocation is only with heap, and dynamic memory allocation is explicit request from the programmer. So until unless as a programmer I require some memory, you cannot get memory from heap. Similarly, as a programmer, if I release the memory, it will not be released. So heap or dynamic memory allocation is always explicit. We have to explicitly get the memory area and explicitly release the memory area, and that is done by the programmer. So this is heap is the programmer's area. It is the kingdom of programmer. Programmer can do can rule this, but remaining area, it is not under control during execution. It is decided by the program, and based on the calling of the function, stock grows and shrinks, and based on the your declaration, the data items get space in static in data area, but heap is the area which is completely under control of the programmer. So when you take the pointers, pointers are very powerful, but they are based on the ability of the programmer. If the programmer can use them properly, you can write very good programs. If the programmer cannot use them properly, then the same program will cause problems. So because pointers are completely under the control of the programmer. See, the main difference between the other languages and C++ is in C++, there are pointers. In Java, there are no pointers. Python, there are no pointers. But there are pointers, but not controlled by the programmer. In C, the pointers are controlled by the programmer. In C, in Java, Python, programmer is not allowed to control. So that is the reason why C is so much flexible. You can do some flexible programs, system level programs, because everything is under the control of the programmer. So dynamic memory means heap, and dynamic memory means explicit. Dynamic memory means programmer's area. This points you have to note, because each time you want some memory area during execution, you have to use heap area, and that is how you can make the data structure grow or shrink during execution. So you will be requesting some memory from heap, you will get it, then the data structure grows. If you release it, then data structure shrinks. So it is completely under the control of the programmer, and it is explicit. So this is one very important point to note with dynamic memory allocation, and it is only with the pointers. It is one more point to notice, it is only with pointers. So this is some brief introduction about the dynamic memory allocation. So dynamic memory allocation is explicit, but in C, when you take the dynamic memory allocation, how do we do the dynamic memory allocation in C? It is with the help of functions, but there are several functions, but mainly we use malloc function. So I'll give first about malloc function. So malloc for memory allocation, for dynamic memory allocation. Dynamic memory allocation. So we use malloc function for dynamic memory allocation. And when you take this dynamic memory allocation, we use malloc function. So we'll take the syntax of this function. So the syntax is void asterisk malloc size of memory in bytes. So this is actually the malloc function used by the programmer to allot memory area. So what malloc function takes as input is the whatever in heap. Suppose if this in heap, this is heap, how much memory area you want in bytes, not in terms of data items. You have to request for, suppose I want 1000 bytes. So 1000 bytes from heap will be allotted. So you should request for memory in terms of bytes, not in terms of number of data items. Suppose if it is you have number of data items, then you must convert it into number of bytes. For example, I want 50 integers, so 50 into size of int. Then you will get the number of bytes. So generally it is 44, 4 into 50, 200 bytes is allotted. So you have to supply the input to the malloc function, which is number of bytes you want, not number of data items. So if you have number of data items, that data item may be integer, or it may be a structure variable, or whatever it is, you must convert that number of data items into bytes. That is one first thing to note. Next thing is it will allot the memory area. The memory area is taken. The memory area is when malloc gives some size, memory area is allotted for the program, but malloc is not aware of the type of the data that is going to be stored. The type of data that is going to be stored here is not known to malloc. So what it does is it will return a void pointer. Void pointer is nothing but a generic pointer. So void pointer, we can say a generic pointer, or void pointer is called as a generic pointer of no type. So because malloc does not know what type of data that is going to be stored, so it returns a generic pointer. So generally when we want a pointer of a specific type, so what we do is we typecast this generic type. So when the pointer is generic pointer, we can typecast always. We can typecast to a specific type. So generally malloc will be associated with typecasting. So because malloc function returns generic pointer, but the pointer we require is specific type of pointer. So generally malloc is associated with typecasting. So typecasting is done to convert. Why typecasting done here is to convert generic pointer into pointer of specific type. Generic pointer to pointer of specific type. Pointer of specific type. So this is a generic pointer. This is a malloc function. But one more point to note with malloc function is you will be requesting for some number of bytes. Either you may be saying I want 1000 bytes, or you may be saying I want 50 integers, but it will be converted into bytes. So whatever you are requesting, suppose that much memory is available, most of the times it is available. If that much memory is available, what malloc does is it will allot on the starting address. Suppose this starting address is 9600. So it returns the starting address. If allotment is successful, what malloc does is it will return starting address of the allotted memory area. Return starting address of allotted memory area. Starting address of allotted memory area. So when so here 9600 will be returned, which is a generic pointer. Then you can typecast and use it. We'll see the example. But suppose by chance whatever requested is requested amount of memory is not available. So allotment is successful. Okay, it returns. If it is not available, so if requested memory is not available, requested amount of memory is not available, then it's a failure. The job is failed. So it is a failure. When it is a failure, what malloc does is malloc returns null, which is nothing but 0. Returns null pointer, which is nothing but 0. Null pointer is nothing but 0. Null pointer. So it is always better after you perform malloc, check whether the return value is a null pointer. If the return value is null pointer, then the operation is failed. So you cannot proceed with whatever activity you are doing because the memory allotment is failed. If it is not null, then it is successful. You can go ahead with the activity. So this is one more very important thing. Each time, generally, when you are writing very simple programs, suppose if you are going for lab programs, it will not fail. But if you are going for very huge programs where you will be using a lot of dynamic memory, there is a possibility that that memory is not available. Then if it is not available, then malloc fails and it returns null. So it is always safe to check the return value of the malloc function before we proceed with the main activity of the data structure. In normal cases, for demo programs where we are using simple programs, there will not be failure. So you can go ahead. But in real time, it is always better to check whether the return value is null or not. If it is null, stop, display error message and stop the program. Otherwise, you can go ahead with the program. So that is how malloc function does. Now, when you take this, one example, one simple example will take it. Simple example will take. So one example, suppose I want structures we can normally use in linked list, but I'll take for integer. So I'll read, I ask the user number of integers required. So I'll say printf number of integers, number of numbers, enter number of numbers required, enter number of numbers. So I'm asking the user to enter. I'll read the number of numbers. I'll read the number of numbers. Then I'll allot the memory area for a pointer. So if I take a pointer p equals to, because now the type of array or memory area you want is integer, so you have to typecache. That is the one point to note. So typecasting is must, because I told you malloc returns generic pointer, then malloc, and you have to mention the size in bytes. So if you have number of data items like this, then multiply it with size of each data item, which is size of each data item is integer. So now n is 100, 100 into 4, 400 bytes is allotted, and then the start 400 bytes is allotted, and p, suppose if this is something like 3600, then p will be having 3600, then it can